Hey, good afternoon. Welcome to BSides. My name is Ken Netzorg, here to introduce an inline traffic analysis appliance for use in Azure. And if your platform allows for it, if you can do a managed routing, you could look to do this in your own platform as well. There's a few there are a few options in Azure, but other than that, you should be able to run this potentially in others. So we'll step through this, and your mileage may vary as you get through it, but we'll see how we go. So why are we here? I spent some time trying to figure out how to run a tap inside of the cloud. Azure doesn't allow for tapping, so I needed to find a way to get in the middle of network traffic in order to evaluate what was going on and whether it was legitimate. In doing the evaluation, I found that there were multiple vendor appliances, but unfortunately those all came with a high cost. So in poking around, I found out we do have the tools. And so here's an introduction, since I had to piece different pieces together to make it all work. So I'll blow through it. But first off, who am I and why am I here talking to you? I've got 25 years of experience throughout the information technology industry, and I like to solve problems, specifically IT related, so we'll keep it to a minimum on the other aspects of it. I'm currently a director of technology at Decisive Edge here in Delaware, and I do have some certifications to my name. So an overview of what we plan to tackle today. I'll run through the architecture, we'll look at the Azure objects that get implemented in order to make this work, some of them OS modifications. Then following that, we'll look at monitoring traffic, what the options are, both from a Suricata, Zeek, which was formerly known as Bro, and just straight TCP dump. Then some high availability options with the following enhancements, hardening, and future options for the configuration. Finishing off with some conclusions and questions. I will be monitoring the chat channel as we go along, so if there's questions, feel free to drop those in. And if we run out of time, hopefully not, since we got 30 minutes to go through this, we'll bounce into the Q&A channel afterward for any future chit-chat. So first, the architecture. What I will introduce today is going to be a simplistic virtual machine with 3 network interface cards, one in the secure environment, basically your internal, one on the public side attached to a public IP address for the outbound, and then a management IP on that side. So we would have a network traffic pattern looking like this to the outside world from the inside world. The advanced architecture I will poke at briefly is going to add some different layers to the basic with multiple virtual machines managed through an inbound load balancer, going through a network address translation gateway on the outbound side. That will give you some fault tolerance and load balancing capabilities. So let's get busy and build this. First off, I designed this with one virtual network split into 3 subnets for the appliances I mentioned, one for the secure management and public IPs, and then a client IP used to get to the device in order to manage the operating system initially, as well as generate some traffic so we could see it. So the object compute, I chose a standard B2S. So one of the critical pieces to look at is what is the size machine you need, minimum, if that's what you're looking for, that actually has the ability to attach 3 NICs to it. So in the Microsoft world, that would be the standard B2S. There's some A's as well that allow it, slightly more expensive, and then you can jump into the D series onbound. If you need some more if you need more capacity for compute, you can rework those as well. But again, the NIC capacity is definitely what you're looking for. Second, when you go to create the Azure virtual machine, make sure you set the NIC into the outbound subnet first. That definitely helps with some of the routing complexities that'll come later, where you don't have to then override what that is going to look like. So in your initial, if you use the wizard, you're going to add 1 NIC as you go along. Then once the machine is up, you can add 2 additional. If you are savvy with scripting, you can do that all at once. I went through the wizard and just worked these 2 in. So that provided a network map that looked similar to what you see there on the right-hand side, where I put ETH1, the Ethernet second one in the secure subnet, and the 3rd NIC in the management subnet. And then, of course, the network security groups that get attached to those, depending on how you've proceeded. We'll address that shortly later. So with Azure, they have the concept of IP forwarding, and that does need to be turned on at the portal level. So on the outbound NIC, I went back in and enabled the IP forwarding. Some other platforms may or may not require this. It is an Azure thing, and I found that it seemed to only be effective on the outbound side. The inbound or management subnets do not need forwarding turned on. So in theory, after you have done all of that, from a platform perspective, you fired up your virtual machine, you should be able to, from your client, log into the operating system. So from here, I launched an SSH connection from the client subnet and went to the to the outbound NIC. That was my first hit. Again, because of the routing complexities, if you didn't deal with asynchronous routing, going to the outbound ETH0 is the first one there, just to at least get logged in. At that point, from there, you can make the next modifications that we come to. So we need to tell the kernel it's now becoming a router. So by default, the kernel has routing turned off. So there are a couple different options to go about that. We can set it dynamically, though it's not persistent, by using the sysctl command shown there. And if we want to make that persistent so it survives restarts, we could actually put that into a file in the sysctl directory as shown there on the screen. This will then set the kernel to allow allow forwarding upon restarts. Or you can just do both. If you want to make it real time, you can set it initially and also set it in the file so that it does survive reboots and you do have it to play with immediately. So once the forwarding is enabled, we go ahead and handle the routing. This is the piece that will allow us now to actually get to our management interface as well as our inbound traffic on the private subnet. So for this, I just use the 201 and 202 IDs within the routing file, attach those to the ETH1 and ETH2 labels. So it helped keep things a little more straight in the naming perspective. So now we've defined a route table, and then we go through for each interface. Being on the Azure platform, Azure will, based on the design, manage your ETH0, your first NIC, for you. So that will define the routing. It'll set up all the DHCP information. So we need to now go in and manage ETH1 and ETH2. So the settings for each of these, as you can see on the screen there, are setting up the route and rules. So the default route within the Azure network, it uses the first IP address of that subnet. So in this particular case, the 16.1 and the 20.1, if you refer back to the original diagram. After that, the rules as far as if you see a packet come in, so either from or to your interface IP address, having those set properly will define those in the table. So that way the routing rules know that when it sees traffic coming into that interface, it knows that it should respond back on that interface. And that's what it'll prove for the magic as we get into ETH2, which in this case is our management interface. We can then connect to that one once we have restarted. So a reboot at this point definitely helps clear things up. enable the routing, enable the forwarding, make sure everything is there. And we can validate that through a quick SSH into the management IP. So we switched over, as you can see here, we're attaching to the 20.4 IP address, and we have a shell at that point. So in summary, as we've worked through this, we have built a network that was split into 3 subnets. I added the 4th to give me a client machine to both connect to and test with, though it's not explicitly required in this case. We added the virtual machine. We had 1 NIC in each of the 3 subnets, and we've made updates to allow us to SSH into the actual management NIC. So with that in place, we should now be able to do what it is we need to do. We should be able to forward the traffic outbound. So from an Iptables perspective, this gives us the ability to NAT the traffic, so do a network address translation from the inbound to the outbound. Iptables is a little bit varied based on your firewall distribution. I have chosen to use Debian for this particular example. You could also be using Red Hat or Ubuntu. So installing Iptables, depending on the platform, it could be Iptables persistent or Iptables services to make sure that when you restart, Iptables truly does start back up again for you. And then where the Iptable stores its files, depending on your flavor, you'll want to make sure you know where that is to be able to edit that. So in our case, we edited on the rules version 4, the rules.v4, and that gave us the ability to add the NAT chain, since Iptables is broken up into different chains. So here, the network address translation chain, we added a post routing rule that says the outbound Ethernet 0, we're going to do a source network address translation, and that is going to be to the Ethernet address that's on your outbound interface. So in this particular case, it is 30.4. We also added a filter chain that basically said, hey, anything coming into Iptables, we are going to accept. So we add the forward option on our inbound ETH1 and tell it we're going to accept it. So for many, you may cringe as we are accepting everything. We're not implying any firewall rules in this particular case. So the benefit is being in a cloud, we can apply the network security groups or ACLs, depending on your platform, around that network interface not being on the host. So instead of managing it at the Iptables level, we'll use the NSGs or ACLs to manage the traffic at the platform level. One less spot to manage it and manipulate it when you need to add a new port for outbound. So once the IP forwarding and routing have been put into place, we need to modify the platform in order to generate and send traffic directly to our interface. So in this particular case for Azure, we did a IP routing rule. Their default route is the quad 0/0, and then we would specify the next hop as the IP address of the appliance we just created. So that would be the inbound secure NIC. In this particular case, we had it at the 16.4 address. We can then assign that to any subnet we need to. In this particular case, we were going to assign it to our client subnet that we created as well early on, and that then allows that client, when it sends any traffic outbound, especially to the internet, it will be sent through our server here that we just created. So what can we do now that we've got traffic being sent to our appliance? What is it initially we can take advantage of? So running a TCP dump is the first way to really validate that your configuration is working. We can run the TCP dump. Running an interface any definitely helps. Make sure that you both get the inbound and the outbound traffic. So both the ETH0 and ETH1 traffic. So it's going both in and out. In this particular screenshot, don't forget that if you are doing this from the client that you're also managing TCP to, you might want to exclude port 22. Otherwise, you're going to get a nice reverb on that one with lots of traffic back and forth. So you'll see that in the screenshot. But generally, if you're going to test that on a different client that's not also SSH'd in, you can limit that to simply the traffic. So that's TCP dump. Suricata actually has a specific section within their system and that within their documentation that shows how to configure an inline Suricata network. So it's actually pretty simple by adding a single line to your IP tables that we've already worked on, and that is just sending it to the NFQ that you can see there that is configured and set up within Suricata. So everything else pretty much remains the same. Follow the documentation within Suricata, and then from there, add the simple line to your IP tables, restart IP tables, and away you go. You now have a full inline working Suricata system. Zeek is another fabulous tool that's out there. I do have some experience running this minimally inline to monitor traffic from point A to point B. But this being an overall cluster diagram that you see there on the screen, showing the difference between the taps, the front ends, the workers, and the managers. For this particular case, this integration and configuration would basically be the tap, the front end, and the worker all combined. So you would need to modify your configuration to send the traffic off to the manager machine once it's done. However, it should work to monitor the traffic ongoing. PF ring would probably also be suggested in order to make sure you can get the throughput and volume. Simplistic testing, I have not found that the need for PF ring is there, but if you take it higher scale, PF ring definitely would be worth looking into. And so you can see the links to the Zeek pages on where it discusses the cluster setup. So those are the basic pieces in order to get to a network traffic monitoring, either with Suricata or with Zeek. And so that to date, however, leaves us a little suspect. We need, in order to make this more high performance, should we be putting any bigger loads behind it, make sure that we put in a load balancer to make sure that we have redundancy and or scale. So if we need to add more systems to our design, or if we need to increase our capacity or actually do maintenance and do restarts, should we only have a single machine, anytime we restarted that machine, we would be cutting off traffic to the outbound world. So Azure allows us to do an inbound load balancer. You can use a basic, what they call a SKU, or a standard SKU would give you a little more sizing with that one. Plus, for a standard SKU, if you are going to be traversing different virtual networks, that would definitely come in handy. There are some limitations with a basic load balancer. Keep in mind, with an inbound load balancer, there are some challenges that come along with this one. It does use a polling heartbeat that's either set to TCP or HTTP to know if that appliance is healthy and allowed to basically be routed to from a traffic perspective. So something will need to be on the service listening on your appliance that would respond to that one. The additional piece with an inbound load balancer is you would need to specify each port that is going to be allowed through that load balancer. So 80, 443, DNS traffic, NTP, depending on where you're getting your timing from, SMTP, different options there to go along with that. So keep that in mind as you are building routes out through that you capture those different ports. There's no need to swap the ports. If you're sending it from 80, you can map it straight onto your inline appliance at 80. We did not make any restrictions, as you recall, on the firewall. So it should be listening across all ports. We just left it at the interface level. And then overlaying the network security groups, there are some hiccups and challenges that you might face with that one. The last time I worked on that one, simply putting a network security group in the path on the secure network did basically break the communication between the load balancer and the network interface. So there's some work to be done with that piece of it, and the standard SKU though might change that one a little bit. Another piece that has recently come up that Microsoft has introduced is an inbound gateway load balancer. So this one is a little more broad. Keep in mind though, it is in preview. So in order to set that one up, you would need to opt into the preview for it. The other option is just keep an eye on it and know it's out there. The goal with this one of the things that made it intriguing is that you can chain different appliances together, and you can, as they say in the documentation, you can integrate virtual appliances transparently into the network path. So where in the past, when Microsoft dove into the network taps, they tied you specifically to a third-party vendor. In this particular case, it seems as though they are going to allow you to use a custom appliance, i.e. what we just built as the back end. And you can say, as the documentation states, you can easily add or remove appliances, as well as scaling. So keep that in mind, keep an eye on that one. It might be of value in the future and provide a little bit more benefit than a standard simple inbound gateway or an inbound load balancer. So that handles the inbound and allowing for scaling on the inbound side. From an outbound side, Microsoft has said their preferred, or at least I guess their best, as they state, is the network address translation, the NAT gateway. However, I'm still scratching my head. The pricing and SLA states that their data path is at least 99.9% available. So just for you guys watching there at home, I did put that down in the bottom right-hand corner, kind of small, but that means you've got 10 minutes of outage time a week. If that's okay with you, I guess 99.9 is your friend. So I don't know. I'm not quite sure how this can be their best solution with a 3 nines. We'll see where that one goes. But those are the other options in the box there for what is allowed, or what I guess options are for outbound IP addresses. Considering this is the best, it works. The other option is, for those familiar with the Azure environment, would be to use another load balancer behind another IP address. So that actually fans as a reverse proxy basically on the outbound side. So those are kind of the two major reasons or major tools you could use on the outbound side. But the NAT gateway, hopefully they improve their SLAs. So here we are. Next steps and considerations. We've kind of discussed so far setting up the virtual machine. We've discussed what we can do to monitor the traffic, how to make this slightly more high performant than the just the basic appliance, and what other things that might be gotchas with this process. So as I mentioned earlier, we have network security groups. Through those, by default, just some of the basic ideas would be on the public, putting a network security group on the public subnet, and only allow outbound. So basically block everything inbound. There should be no need for one NIC to communicate with another or any traffic to be inbound. So you can pretty much deny everything inbound. Keep in mind it is stateful, so any traffic going back out would be allowed back in, but you wouldn't need to accept any inbound unsolicited traffic. The secure channel, on the secure NIC, definitely would be ideal to put a network security group there. Keep in mind it might take a little bit of trial and error to get that network security group up and going, even though the load balancer would be allowed through there by default. And then you have the third NIC, which would be the management NIC. Definitely with that one, limit your connections into that subnet from anything you trust, and SSH, block everything else at that point. So that should take care of your security from a platform perspective and network traffic. Then of course you have SSH. This one, in theory, should be listening on ETH2. One of the challenges I found is with the load balancer, if it needs a heartbeat, the question is going to be what is actually running on that appliance to respond to a heartbeat. So SSH, for better or for worse, you can run it on a separate port, might be one option for a heartbeat to answer. Suggestions, if anyone else has anything else, definitely might be interested in seeing what there is, but adding more services only increases the footprint and complexity and risk at that point. So keep that one in mind. The other issue is if you don't install 22 SSH on the inbound, which might be ideal. Should you ever have to send SSH through the device, you don't want the SSH daemon on this particular appliance listening and responding. You want that SSH traffic routed through the appliance, not responded to. So you might need to update the SSH daemon. Keep that one in mind as you're progressing through your installation. Iptables, for those familiar with the Linux world, we are turning a corner. Iptables is on its way out. Iptables is coming around. It's a little more complex to set up. I have not yet had the pleasure or pain of dealing with converting this installation into a network tables format. So unfortunately, I don't have anything to give you at the moment from a configuration perspective. Maybe in time I'll get that out there. So wrapping this up, hopefully this has been helpful. We've shown that you can build your own appliance using some cost-effective resources. At the end of the day, it's the cost of the virtual machine. In the Azure world, throw a reservation on it and you probably have something that you can use for about $40 a month. Far better than just about anything you're going to find out there that's commercially viable at hundreds easily per month. The appliance can be outfitted with your own product that you choose. So again, choosing open source, Suricata or Zeek, you could even tie that into a security onion, feed that stuff into a Rita or your other AC Hunter to monitor your traffic. And then using different cloud services, you should be able to increase the availability and throughput so you don't you're not relying on just that one device serving that up. Hopefully that's been helpful. If there's any questions or comments, definitely monitor the Q&A channel. So with that, if you need to contact me, I wish you luck on your hunting and getting it up and running. I am Zorg the Blue on the Discord channel, and I will try and post something out there on the GitHub that I've got. I don't have these slides up there yet, but I'll work on putting something together before too long. So hopefully that's been helpful, and appreciate everybody's time.